energy resources. In this book there's an article about it, and there's something said, so I went now here where one can see some different ones from here. Where said one which is used a lot is coal. That wasn't a lot used. This is here in Britain. There is the book saying that there were 200 million tons produced 1950 and 2050 million. And also the people working have gone from 700,000 down to 17,000 in 2000. And also 1,000 coal mines have closed in Britain. So down there, there's almost nothing anymore with coal. There was some time ago a big industry thing with multiple big towers, and I think they made coal. I don't know it exactly, but they are no longer standing there. Somewhere at the southern side of the river. So down there one can maybe see in the middle of all the buildings, there's the big Tees River going through. And south of it in Middlesbrough, there's still the Wilton plant that uses, I think, still coal. There's also a railway line going through, so people have dug up coal underneath the earth. In Britain, 1,000 mines have closed, so coal is reduced in Britain in the last decades. And they've brought it with railways everywhere here through the railway tracks from the South Durham coal fields down to the harbour of Hartlepool, and was then brought also, I think, also to other countries, but certainly from some places, I don't know how now to Middlesbrough, but to Hartlepool was a lot brought from the South Durham coal fields. I don't know how to Middlesbrough. Also there's coal brought too, also with ships and so on. The railways are different forms, how it can be brought to some places. There in Middlesbrough, I don't know it exactly. There is still the Wilton plant where I think coal is burned to heat with it things. One can also burn gas or oil or technically also wood or other things. They are burning and heating up water in a tank over them or going with pipes through them. There are different ways, and that produces then vapor, and water is expanding, and the vapor has an incredible force. One cannot stop the water from being heated up when it is over the flame. What can there happen differently? That is heating up if one holds a flame underneath water. One cannot stop it. And it is expanding when it is heating up. One can also not stop that. Yes, one can very strongly keep it together, but it has an incredible force to go to the side. So if one makes fire underneath of water, the water will get hotter, and the water, through getting hotter, will get bigger, or it will vaporize, and the vapor will be bigger of a steam. And that will press them with an incredible force, which is not stoppable onwards. It is pressing through a turbine, the turbine is turning, and when that is turning, a block of iron inside of copper wire. And it is just so that they are magnetic. There are things which are magnetic, and they are magnetic, and they have an electric field, and these electric fields of the iron block and the copper wire are interfering. Every time it is turned, they are interfering like two magnets together, and that creates, there is something invisible magnetism going on, and that is an incredible strong force also, and an unstoppable force. And it is creating then electricity, just because of a friction. That is just how it is. It creates electricity. Then electricity is taken and through grids brought to other places. I can't see one with these things went to other places. So that is the mechanism of a turning thing, which can be done with coal, but also with oil or with other things. So down there would be coal. Then another thing would be oil. Oil is also not so much used in this place here, but there is a big oil refinery. Down there's a big block visible. That is a nuclear plant, but a bit south of the river, just behind it, I can't be seen from here, there's a big oil refinery. And out there in the North Sea, there is a place, it was together 200 million years ago. Norway and Germany and other places were together, and there was a land, and there were dinosaurs living, and many plants were there over a lot of time, but they even died, and the plants were there, and all was then lying around there. And when the Zechsteins, they filled in again, when they drifted apart, or did the water rise, something happened there, and now there's the North Sea. And now underneath the North Sea, underneath the soil, there's big places where plants and dinosaurs and other things are rotting, and like a bread or an apple somewhere forgotten for a few weeks, it gets brown, fouly, it changes the color. I don't know how it works exactly. It is then going over, I think, even multiple steps to oil, and technically in other places also to coal. It's a similar process. I don't know the exact differences. So there are all these plants and they are lying there underneath the earth now, underneath the sea. And they have found there since 200 million years ago. So it's not a little bit moldy, but it has completely changed through multiple steps. I don't know it exactly, to oil, so a black substance. And that substance can be pumped up. And they're doing that. They have 30 platforms out in the ocean standing, pumping it up and bringing it with pipelines. One pipeline is bringing some type of gas to Germany, to Emden, and another pipeline is bringing oil to the ConocoPhillips oil refinery down there. They can't be exactly seen from here, down there. And also to the Graham tank farms. They store it there, they can store it for 1 week, and they are refining there the oil. I don't know what it means, but they're taking there the oil, they're heating it up, taking different substances out of it, they're making also NGL, natural gas liquid, they're heating it up and taking the hydro things out of it or something, they're doing stuff with it, and then comes better oil out of it or something. And then every day they're bringing one tanker, they have 300 a year, so every day there's one big tanker, one big ship with a big belly, and they're pumping their thousands of liters, I don't know how much, of oil in it, and then they're bringing it mostly to the Netherlands, and from there it is brought on to Europe. So here's a lot of oil taken from the North Sea, it's actually Norwegian sea field, Ersk field, it's actually a part of, it is a sector said to be regulated by Norway. It is brought here and refined, changed, and with ships brought to the Netherlands and then on. So oil is not fired here, but refined and then in Europe fired, burned with it. Same mechanism. Oil is again heating something up, turning a turbine, making electricity, or oil can be also used directly in heating. When the people get they have not just ships with a big belly full of oil, but also trucks. There's a whole truck and behind of a bag full of oil, driving to the peoples and giving them then. These peoples, they have in their homes another big tank standing, or multiple of them, and they're pumping then the oil in, and then they have the heater, I don't know what it's called. The heater standing, the heater is taking always a little bit of the oil, burning it, and then they're burning, I think, when water, and the hot water is, so the people have in their homes a big heater standing, which is taking a little bit of the oil, and that oil is then burned, and that heats then water up, but that water is now not producing electricity. People are not producing electricity in their own homes normally, but they are heating water up, and the water is then pumped through pipes through the house to different places where things are standing, where the hot water is then in, and the hot water that's standing in there heats the room. Electricity do the people get directly through that. In Europe, they're using a lot of coal to do that. They are, as I explained at the beginning, they are burning then at such factories big coal, and when they're getting the electricity over the grids, over the air, and then through little cables, get the electricity, and the heating do we produce by them at home. There are also other types we get when the water directly, we heated up water, but that is just the marginal people do it. Most people are burning oil. Some people are also burning wood at their home, some people gas. These are the 3 or 4 things which are mostly done. So there's oil. Oil can be made. Oil is not happening to burn here, but it is made here so that other people in Europe can heat with it. And also people drive with it. There are many cars who are using some types of oils. I don't understand the differences. They are refining it in different ways when it has different parts in it, but it is still at the end of the day mostly oil. There's diesel and benzene and 10 other similar forms. And they're putting it in their cars. Their cars have also a tank, and then they are taking, every time a little bit is taken out of it, just a little droplet, and that is put into a little thing. And where it is exploding in, it is heated up when the oil is exploding, and that presses a piston, is it I think called, up, and they have 3 or 4 or 5 or 6, maybe even more. I think there are even 12 or so or more. Most people have 3, 4, 5 of these things, and they are then pressing up and down, and so I don't know exactly. And that is when, at the end of the day, somehow turning the wheel. There's one going up and one down, and if one takes it like that, that would turn the wheel of the car, and when the car is driving. So they're also driving a lot of the types of oil. There's also electricity. Some people using also electricity to drive with them. I don't know exactly how that works. So that is oil. Another thing would be gas, also done there at the oil refinery. 70,000 barrels, I think, do they do of natural gas liquid per day. And there's also, that can't be seen from here too small, a little place at the salt or something. There's also gas made. It's not so much, but it is to balance things out. So gas can be burned in a similar way. It is also burning. It is even more explosive. It is similar to gas, but a little bit differently. And it also, like coal, comes similar through the things. I don't know the difference. Oftentimes there's oil down in the chambers lying underneath the ocean or underneath the earth, and then gas on top of it. It results in a similar process. I don't know the exact differences. So gas can be also used to fire things. Same principle, heating something up, turning something, same thing. And then nuclear. I don't know exactly how that works. They're taking uranium that can be found at some places in the earth. And when they're doing something with it, and the uranium is having radiation out of it, that is just so. It is just an element which is decaying. Some elements are stable, they are just staying like that, and other elements are decaying. I don't know the chemical reason for it, what it was. They are breaking apart, and while that is happening, energy is released, and that is a lot. And they're doing there in that big block. There they're having, I don't know it exactly, but they're having uranium that is falling apart, releasing energy, and they can take it and having then electricity. That is producing a lot of electricity for the region here. And then the other energy forms. There are also other energy forms. For example, here. There is a solar field. It is way bigger than that. It goes here all on. But here can be a little bit seen. And there are semiconductors in. Again, chemistry. There's on one side is silicon and phosphorus, and on the other side of the solar plate is silicon and boron. And the sun is shining, and when the sun is burning, there are photons released. In the sun, there is a lot of hydrogen. There is just a space in the space out there is a lot of interstellar dust. It is just where humans don't know yet why. And everything which exists and has a mass or a way is pulling in other things. The Earth is very, very big, so that thing is pulling in pretty strongly. So I can jump up, but I immediately press back to the Earth. And also a little thing has gravitation. Also this finger is pulling in the other one. That is of course pretty close, so it doesn't happen. It isn't feelable, it's not strong enough. But out there in space there can be such a big place that it is so much there that it is actually falling together. This dust is accumulating and it gets so much that it is pressing stronger and stronger on top of it. The more there is, the stronger all is crumbling together. Incredibly strong. And at some time it is so strongly pressing together that two hydrogen atoms, or four, I think it were four, are melting together, fusing together, and becoming helium. And while that is happening, there's energy released, an incredible amount of energy. So that when the sun is there, here on the Earth, it's quite far away from it, I forgot how far it was, then still the heat is on the Earth. And the heat and what the sun is doing is existing. It doesn't have mass, it can travel with the speed of light, with 300,000 kilometers per second, but it is existing. It doesn't have any mass, it doesn't weigh anything, light doesn't weigh anything, but it exists, it is something. It is heating up things, it can burn the skin with the ultraviolet light, it makes things warm, and so on. It creates the wind, because the air is heating up, and when the air is heating up, it is rising up because it has greater expansion and takes little amount of place in it, and then it goes up into the air. I don't know how it exactly works. So in that way, wind is created, and when the wind is blowing, but also the sunlight is photons. And if such a photon comes, then it hits the silicon and the phosphorus, and they have one electron too much. Silicon has 4 electrons. That is how chemistry is working, how elements are. Silicon is a substance. It is, I think, the most abundant substance on the Earth. Sand is a lot of silicon. And that has 4 electrons. That is just how the world is. It has 4 electrons on the outer shell. And phosphorus, that has 5. And they now have 9 together. And they don't only 8. They have 1 too much. They want to get rid of it. The photon comes and hits the 9th electron and pushes it over to the other side of a solar plate where there is silicon and boron. Boron has only 3 electrons, so together with the 4 of silicon, 7, they want 1. So where we have 1 who want to get rid of 1, they want 1. The photon is pushing or exciting the electron over, and that way there is a current flowing. An electron which is moving is a flowing current. Electron, electricity, a moving current, a moving electricity. Electricity is generated through a photon hitting the electron, bringing it over to the other side. Electricity was generated. I don't know how the electricity is not taken out of or whatever, but that is happening right now there. A photon is hitting 1 electron on the top layer, bringing it down to the other layer, and electricity was generated. That is another form. Another form is when wind, that is happening there. As I said, the sun is heating up the air. The air is rising and moving, and wind is blowing. And that wind can hit again the wings of sails, of the wings of the wind turbine, of the whole thing there, and when it is turning. They are pretty big. From here it maybe looks just 2 meters big or 10 meters big. I don't know how big that one is, but let's say it's 60 meters high. So 20 meters as high as this tree, and also these wings to the sides, they are also 20, 30 meters long. They can be even longer. So that is moving incredibly fast. If one is taking just an arm and moves it now with the speed as this is turning, now this would be around 1 meter per second. But now if they are 30 meters long, that means that that wing on the side is going completely to the other side. Actually is moving 100 meters a second, or I don't know how fast that would be now. Let's say 30 meters per second or so is that now. But that is not the important part. The important part is that there is an incredibly big pressure. These wings are very big and no one can just stop them. They are having a lot of pressure, and the same mechanism. Inside of them, I don't know it exactly, but there is iron turning inside, turned through the wings. The wings are turning the iron block inside of copper wire. Again, an interfering electromagnetic field. Electricity is generated. Another form is hydroelectric power. That is water. The sun is evaporating things. If one lets down laundry in the garden out, the laundry will be, if it isn't raining, dry after a few hours or a few days, depending on how much water was in them, what material are there, how much wind is blowing, because when they're drying faster, if there's wind blowing, because more air without water in it is coming against the clothes and going with water again on, more water is taken out, depending on how much the sun is shining, how much humidity there is, and so on. The point is, laundry is getting dry, and puddles and lakes are getting dry. When it has rained, the street and all here is a brook flowing and so on, but when it's flowing, but things are getting dry through the sun. All there over the sea, the sun is evaporating the water. That is how it works. The sun is evaporating the water. The water comes into the air, into clouds, and when there's too much, it's falling down. And when it is falling down, it is falling not down over the ocean, but just over the land again. And when it is running as rivers down, there is the Tees River, for example. It is falling there all in Britain, around York and in other places. All there it is falling down the rain. And now all the water from here is going to there. We are a little bit too far off. It would go maybe about over the Crimpton Deck or the Burn Valley and other brooks into the North Sea. But a lot of rain falling in that region will go down through the Tees River down and much more inland. And all that water is there. And it can't be stopped. It has an incredible force pushing on. Water is evaporating and more is accumulating than the river. If one makes now a barrier there, then the water is not just peacefully flowing out into the ocean, but it will be stopped there, and there's an incredible big force pressing against the dam. If one makes now one hole into the dam, the water is pressing through it, and one can set in a turbine against something turning. The things, they are standing like that, so that the water is pressing against it, it is pressing easier to that side. So the water or the wind, all the same thing, the water is going here, and then it has easier to go here to that side. Because why should it go from here when it has to turn it? So it's going to that side, and then the wing is turning like that. Or maybe it was the other way around. The point is, it is turning it to one side. And when the whole thing is turning, it is turning, same thing, iron turning within of copper wire, and electricity is generated. So these are the forms. Coal out of the ground, which were also plants pressed there. There's one disadvantage, that is, so not to our recapitulation of what is going on here, to the analysis. There are resources which are renewable and non-renewable. And all the ones from the ground are more or less seen as non-renewable. The reason for that is it takes millions of years and millions of dinosaurs and plants and trees to die and lie on the ground, and then millions of years to create new oil. Human beings live just a few decades, and thinking even in generations, human beings cannot wait millions or hundreds of millions of years until new coal, similar process, trees underneath the earth, under heat also and pressure forming to coal. Humans cannot wait for that millions of years, or for oil or for gas. Human beings cannot wait for that. I didn't say the trees can be also burned, and they would grow new after a century if one is not taking too much at one time and lets them 100 years to grow again. Then trees can be also taken to heat something up or to cook or other things. Now, some things taken quite long, and so these ones, they are taking too long. They are non-renewable. They are taking millions of years to regenerate again. In human terms, not possible. And then the ones which are renewable, in absolute terms, also the sun has a finite amount of energy. After some time, all the hydrogen in it has fused up to become helium. The sun isn't big enough probably, but there could be happening that the helium is then also fusing on to the next things, and when it's falling strong together, becoming a white dwarf and so on, it is crumbling stronger together. The sun isn't big enough. It's not a big sun, the one which is connected with the earth. Yes, also the sun will burn out is the point of what I hear telling, but not in human terms. That will take as well hundreds of millions of years. So in human terms, the sun will burn forever, and coal is not regenerating. So forever in human terms, will there be the sun shining and creating wind on the earth, turning the wind turbines, the sun shining, pushing the photons and the phosphorus over to the boron, creating electricity, letting the rain fall down, pressing against dams where hydroelectric power can be made with the turbines. So the ones taking too long for in human terms, the other ones are in human terms forever there. Then some overall disadvantages: if the wind is stopping, then it wouldn't turn. If the sun wouldn't shine, they wouldn't produce. It doesn't happen too often that the wind is not shining and the sun is not there. The rivers are almost always there. The Tees River, it is unlikely that it will dry out in human terms ever. So if one uses different ones together, there one could say that there's always something. A similar thing with the oil. They are getting now the oil from Norway. So Britain and Norway have to be at good political terms, but Norway is sending the oil over to Britain. Britain has to be at good terms with the Netherlands, and the Netherlands have to be with good terms with Europe, so that the oil is then also not stopped because of disagreements, as the sun could be through the clouds or something. So there can be that it is not all the time there. Then the next thing is that not all humans are using the same amount of resources said in the book. They said that in some countries, they're considering Britain as one of them, where the human beings needing quite a lot of energy. There are many people living, but there is much more in electricity generated and at resources burned in comparison to other places in the earth where there are not so many people living, or there are more people living who are not using so much. So the book is saying that in Britain there are people living, but they're using a lot of energy. In other places there are more people living and they're using less energy. That is another thing. So here's a lot of energy used, but that is not so much know about the resources. So do I have anything else less to say? So there are different forms of energy, all used to heat things up, to make it warm so that humans doesn't have to freeze, to cook things because human beings prefer to eat some things cooked, and also some things can only be eaten cooked, and also to drive cars or other things, to be mobile, and to industry. Some things can be only produced with electricity or with other things together, and they are using resources for that, and there can be the ones: oil, coal, nuclear, gas, or hydroelectric. Could be possible, there is no hydroelectric at the Tees River, or solar or wind, or until someone has another idea how to make things. Geothermal would be another thing. There is taking the heat of the earth inside of the earth that is also very hot, and that heat is in some places coming close to the surface at volcan areas and geyser areas and so on. That heat can be also taken. Heat is the motor of many things. So that are resources. I think I said enough and all what I had to say. According to Geography by Jane Ferretti and Brian Grizzly on the page 98 and 99. The positions and views expressed There's other ones of a source and don't necessarily align with my own or with the ones of the entities spoken of.